Okay, awesome. Thank you. Good afternoon. Welcome to the AWS 2021 Summit. My name is Maria Christensen. I am your room host. Before we get started, I do have a few housekeeping notes for you. The emergency exits are out this door to the right, as well as the closest bathrooms. And please remember to silence your cell phones if you haven't done so, actually, and all of your other devices. As well as if you haven't downloaded the AWS event app, please download that so you can finish the survey at the end of this session. And for this session, please welcome to the stage Mike.
Hi, everyone. My name is Mike George. I'm a senior solutions architect with AWS.
And my name is Alicia Morrison, and I work for Mercy Corps, the Technology for Development and Crisis Analytics section.
So this is session Run 213. We're going to be talking about how you can leverage Elasticity for crisis analytics. So we're going to start out by talking about who Mercy Corps is and what their core mission is. And we'll then talk about the concept of elasticity and how that applies to small development teams. Mercy Corps is using a couple of AWS services, so we'll then go through those briefly and then get into a deep dive on the Mercy Corps solution.
So Mercy Corps is an international nonprofit humanitarian organization. We work in approximately 40 countries across 17 different focus areas, which range from agriculture to gender equality, water sanitation and hygiene, youth programming, and of course, we have technology for development. Globally, there are about 235 million people in need of humanitarian assistance today. And in 2020, the best funded national humanitarian response met only about 44% of the total estimated need. So when we talk about why we're using AWS and why we're talking about some of these tools and data, what we're really talking about is how we're trying to support Mercy Corps programs in figuring out how to best apply each and every single dollar that they have. And we're using AWS to identify entry points for improving that data-driven decision-making process, especially with reference to our work in crisis analytics. So what is crisis analytics exactly? At its core, crisis analytics is really looking to provide actionable insight using data and information. We do this quantitatively, of course, but most of the work is actually qualitative. So why is it important that we kind of do this, right? Let's talk a little bit about the definition of humanitarian access. Access is the ability of humanitarian teams to get aid to people who need it in the place where they need it. And that's impacted by people's ability to access services, but also our ability to give those services. So that can be affected by all kinds of things. It can be just geography, it can be conflict, it can be who the individual humanitarian doing the aid work is, and it can be what kind of aid that they're providing that affects our access. So crisis analytics becomes really pertinent when we start to think about this continuum of access, right? When there's less access, we want to use data because we can't go out on the ground and understand for ourselves what's happening and make decisions, right? So we're relying on somebody who does have access to transmit that data back to us and help us make decisions when we can't go into those places ourselves. And obviously, there are places where nobody has access, and when that's the case, it can be extremely difficult to do any kind of humanitarian work. But when some folks have access and some folks don't, this sort of exchange of information and data is really important. And I kept a small copy of the map up here. These are the locations where we currently have crisis analytics teams working. So you can imagine the challenges in humanitarian access when we're talking about working in places like the Democratic Republic of the Congo, or Syria, or Afghanistan. You can see how this is a problem that we really need to grapple with. So there are some unique challenges in crisis analytics specifically, and especially in quantitative crisis analytics. The first one is that our teams are really small. These are often just a couple of analysts. Sometimes it's just one guy or girl. And a lot of times these folks focus on qualitative analysis, and they have a really deep contextual understanding of the environment, and they're looking at how political and economic policies and changes might affect how humanitarian aid can be provisioned on the ground. Because those analysts are contextual experts, they also have very limited technical bandwidth. They usually have an idea of how to use data, how they want to use data, how data can help them, but they aren't technical specialists, and they often aren't even really quantitative data analysts. And usually money is extremely tight, as we've talked about it, so hiring somebody with those quantitative skills or an AWS developer is not going to be in the budget. And then lastly, the biggest challenge that we have in crisis analytics is that all the information we're getting comes from a lot of different sources, right? It's from all these organizations that are working across the country, the different countries. That information can come in various formats. Sometimes it's published in a PDF. Sometimes it's a multi-tab Excel sheet. Very rarely is it a nice, tidy CSV with standard headers and a stable schema. So this data often needs a lot of cleaning and processing. And again, because of the limited technical bandwidth that we have, it's really difficult for our teams to kind of grapple with more than one piece of information at a time. And often I'm the primary technical specialist that's helping them trying to solve those problems. So we talked a lot with our teams, and sort of given those three major constraints that I just mentioned, we identified that what they're really trying to accomplish with use of AWS is three major tasks, right? The first is data collection, which is just automating solutions for cleaning and processing and giving them the ability to integrate data sources from different places so that they can understand how data interacts. The second thing is data storage, making sure that data is stored securely, especially in the humanitarian space. Oftentimes data could be proprietary, or it could just be dangerous to be publishing it publicly. So we want to make sure that the right people have access, and oftentimes only the right people. And then the last piece is data analysis, of course. We want to be able to visualize, analyze, and interact with the data that we've worked so hard to kind of collect and store securely. So, given that introduction, I'm going to talk about a couple of use cases that we've started. The first is on forecasting affordability in Syria. Here's Syria. So you probably know that the conflict began in 2010. It's the world's largest displacement crisis with more than 13 million people in need of humanitarian aid. But I think the critical point on this slide is that the price of a food basket, the price of your basic needs for food, has increased more than 3 times just in the last couple of years. As I mentioned, data is fragmented, collections often interrupted, and it comes in varying formats, sources, and quality. It's hard to grapple with data from Syria because it's coming from all over the place and being published by all sorts of different organizations. So what's the actual challenge here? The actual challenge is, how can we predict the number of people who will need humanitarian food aid in Syria? So just a couple of concepts that are important to understand why that's a challenge that we need to figure out. So first is that the minimum expenditure basket is just a list of requirements by country for a household in that country to meet basic or essential needs on a regular basis. So it varies from country to country. In some places, rice is really important. In other countries, bread might be really important. And this can include both food and non-food items. So it might be hygiene items, so feminine hygiene products, anything that is available on the local market, whatever that costs, that total cost of those items is added up into a minimum expenditure basket. This is sort of roughly equivalent conceptually to a poverty line. So it's a marker of how much aid we might need to provide somebody. If they can afford those basic items, then they may not need as much aid. If they can't afford those basic items, then we're trying to find a way to get it to them. So the concept of affordability is a function of wages and costs. So when costs are rising faster than wages, workers have to work more hours in order to afford that basic basket of necessities. So you can kind of calculate out when things become unaffordable because you can't work enough hours to afford that minimum expenditure basket anymore. So the ability to forecast out what wages will be and what the price of that food basket will be 3 or 6 months in the future is really important to humanitarians who are trying to plan for how much resources and where those resources should be applied in the future. So I'm going to tell a little bit of a story here on how we thought AWS could help us with this problem. So we're working on doing a forecasting. We wanted to forecast the prices of those individual food items in the minimum expenditure basket, and this was really early on. We were able to kind of put a model together, and we wanted to deploy a dashboard in order for the team to look at those results on a regular basis. And so we wanted to just put it on a public IP, proof of concept, super easy. So I went online and I found a quick tutorial on how to deploy this very silly looking dashboard onto that public IP. And I found that tutorial, it's told me how to put it onto Elastic Beanstalk. And so I walked through that tutorial and I got done with it and I clicked run and nothing happened. So I called up Mike and I said, listen, Mike, this is my problem. This is what I'm trying to accomplish. Like, what did I do wrong? Here's the tutorial I followed. And Mike was extremely diplomatic about it, as he always is, and he said, well, Alicia, how much of this are you actually trying to manage yourself? And the answer is none management. I do not want to manage my own tools. I am just me. I'm a solo sort of data scientist on the crisis analytics team, so I don't have time to do all of the network engineering and all of the data science and all of the maintenance and all of these other things. So I didn't want to do any of the back-end management if I could avoid it. So Mike started talking to us about some of the concepts he's going to discuss in a second. And he said, let's look at this management continuum. And maybe we should talk about putting it on Fargate. Because Fargate requires you to do a lot less management on the back end. So Mike gave us a little walkthrough of Fargate. And we took us a couple of hours, and we managed to get that dashboard deployed almost immediately. And so this example it just sort of represents why we started thinking about this idea of the management continuum and how we're putting together our processing pipelines and modeling pipelines so that it's easy to manage when you have just one or two people to actually do that management. So I'm going to pass this over to Mike to kind of talk about the technical aspects of that.
All right, so let's talk about what we mean when we talk about elasticity. And typically when we talk about elasticity, we frame that in the conversation around a large shopping event, like a Black Friday event. Or maybe I'm a new nonprofit and I release my website. I release my website, I have a few people hit my site, and then as my influence grows, I have more people hit my site, I scale up my servers, and then I continue to become more and more popular, more and more influential, and I continue to scale up my site. And using this concept of elasticity, I'm only paying for what I'm using, and I only provision servers when I need them. But there's a little more to elasticity that we want to talk about than just scaling as it relates to an event. So let's look at this continuum of different services. And if you look at the top line, some of our compute services, really for all of the AWS services, there's this spectrum of management that you have to perform. In the case of EC2, you're responsible for managing everything from the operating system on up. Whereas on the opposite side of the spectrum, with AWS Lambda, you're only responsible for managing the actual function that you want to execute within Lambda. Then if you look at all the other compute offerings, again, there's this spectrum of some amount of management that you either do or don't have to perform. Likewise, when we look at some of our data services like Amazon EMR, with Amazon EMR, there's a lot less management you have to do there than if you were to run your own EMR cluster. But you still have to worry about different framework versions. You still have to connect your EMR cluster to a VPC. You have to worry about routing. So there is some management you have to worry about. Versus with AWS Glue, there's almost no management you have to worry about there. You just provide a script or you provide a job that you want Glue to execute, and it does it for you. Likewise, with our machine learning offerings, with Amazon SageMaker, there's not as much work you have to do managing SageMaker as there is running machine learning on an EC2 instance, but you still have to know about some of the machine learning libraries. Like you have to know about the SageMaker API. You have to know about pandas, NumPy, some of those standard libraries. Versus with Amazon Forecast, you just provide data and it provides you a model. So the idea here is to, if you're a smaller organization, is to index on these services that have less management. Now, what ends up happening if you have a smaller organization, but you decide to use a service that requires more management? Well, let's look at an example there. So say that we have some users that are coming into our site, and I have a cloud account, and I want to have my users hit a website that I want to deploy. Well, I've got to create a VPC. I've got to have that VPC span multiple availability zones. I've got to create public and private subnets, and I put my website in my private subnet. I put that in an auto-scaling group so that it's always available. I front that with a load balancer and put an internet gateway on my VPC. Now, at this point, my website is available to access, but if I want to add anything else, there's more complexity. So if I want to add a database or maybe have access to a file share, okay, well, I've got to create more private subnets. I've got to put a database cluster in there. I've got to create an Amazon EFS share. And then I need to create a Bastion host because I need to manage my website. To make sure that Bastion's always available, I put that in an auto-scaling group so that I can perform updates on my website. I've got to put a NAT gateway in my public subnets. So there's a lot of complexity here. To make my website available, I now have to front it with Route 53 and a CloudFront distribution. So again, at this point, there's a ton of complexity. And this is a fine architecture if you have an IT group that is used to some of these concepts. But if you're one or two people, it's not fair to ask you to, as a data scientist, to also be a database administrator and a storage admin and a VM administrator and all the things you have to manage here. And notice I haven't even spoken about security groups or VPC routing or anything like that. So again, there's a ton of complexity. So how do we solve this? Well, looking back at our continuum, the idea is to really index on these services that require less management. And as you index towards these services that require less management, you're going to find that a lot of these services tend to be opinionated, meaning that they do one or two things really well in a very specific way. But if you're able to embrace the opinionated nature of these services, you're going to be able to scale your organization beyond what you ever could before, and that's exactly what Mercy Corps is doing. All right, so there are two services in particular that I want to talk about that Mercy Corps has really gotten a lot of mileage out of, and that's AWS Glue and Amazon Forecast. So let's dive into those really briefly. So AWS Glue is a serverless data integration service that makes it easy to prepare data for analytics, machine learning, and application development. Glue provides all the capabilities you need for data integration so that you can focus on getting insights out of your data instead of spending time managing infrastructure to get your data into the right format. And if you think about traditional data integration tasks, they're complex and they're typically iterative. They involve multiple steps, such as extracting your data, enriching it, cleaning it, normalizing it, combining it, and then trying to put it into data lakes, databases, and data warehouses. And these tasks are often done by different people using different tools. So Glue makes it easy by providing both a code-based and a visual interface that you can use to make it easier to analyze your data. And there's two main tools that I want to talk about with AWS Glue. That's AWS Glue Data Brew and AWS Glue Studio. So Glue Studio makes it really easy to run ETL jobs. Again, there's a simple visual interface that you can use to create your Glue jobs where you can then monitor and make sure that your job is doing what you expect it to do. And Glue Studio makes it really easy to perform ETL tasks. And it's a great way to get into Glue, especially for people that are new to Apache Spark programming or who are used to ETL jobs with drag and drop interfaces. With Glue Data Brew, this has really become necessary because of all the data collection that's happening by organizations over the last 5 to 10 years. And again, like I mentioned, if you want to prepare data for machine learning, there's a lot of things you have to do. So data analysts would typically take data, put it into spreadsheets to look at the data and figure out what exactly they can do with it. Or they've had to work with ETL developers to extract the data and put it in the right format so that they can use. Now, if you've ever worked with ETL developers, many times they have other things to work on, and so it can take days or weeks or even months until you have the data in the format that you need. Well, Glue Data Brew makes it easy because it's a visual interface with over 250 built-in transformations to normalize your data and get it into the format that you need. And you can save these normalization tasks into steps that you can then re-execute against new data as it comes in later on. And with everything within Glue, it's pay as you go, so you don't have to worry about provisioning any servers or infrastructure or anything like that. And so if you're able to embrace tools like AWS Glue, like Mercy Corps has been able to do, you can continue to scale your organization beyond what you've ever been able to do before. And that's really what we're talking about when we talk about elasticity in the case of small development teams. Mercy Corps has also got a lot of use out of Amazon Forecast. Alicia talked briefly about how analyzing the cost of a food basket is fundamentally a forecasting problem. So before I talk too much about Amazon Forecast, it's worth just reminding everyone of the AWS machine learning stack so we know where Forecast lives in this stack. So we have 3 layers of our machine learning services. We have an AI services layer. That's really consists of these services that are opinionated, where you provide data and the service provides you a prediction, okay? So if you have a problem that fits these services, that's what I would recommend you use. The next layer down, our ML services layer, are designed for individuals that have a little more experience with machine learning. They can get deeper into SageMaker, into writing machine learning scripts. They have experience with some of the machine learning algorithms, but you still don't have to manage infrastructure. And then finally, that bottom layer, the frameworks and infrastructure, are designed for machine learning practitioners that really like to do it yourself. They have extensive experience with frameworks and with managing infrastructure. So, as you might guess, Amazon Forecast lives in this top layer. Again, it's an opinionated service that you provide data to and it gives you a model. So before I get too much into how Amazon Forecast works, it's worth just mentioning briefly where it came from. So it's really designed, or it's really built out of the 20 plus years of forecasting experience done on Amazon.com. And at Amazon.com, they began first of all by building statistical models to perform predictions. And that worked well for the most part, but they ran into complexity and limitations as the product assortment on Amazon.com became more complex and as supply chains became more varied. They began investing then in machine learning methods in the mid-2000s, and those worked fairly well. And then about 2015, they began investing in deep learning techniques. And those really ended up being able to provide predictions that not only learn from historical data, but also learn from subtle relationships in their product catalog. So that's really where Amazon Forecast came from. And even though it was designed or was built from the retail side of the business, it can really be applied to any kind of forecasting problem. At the end of the day, Amazon Forecast gives you a simple API that you can plug in to your application. And it's also important to note, Alicia mentioned how important it is for the data to be secure. Well, with Amazon Forecast, only your data is used to build your model. Your model is not used, or your data is not used in anyone else's model, and your data is encrypted so that it's safe and secure. And there's a lot under the hood with Amazon Forecast. As you provide your data, it inspects your data, it fills the gaps if there are any, it identifies the features in your data, and it then begins looking at different machine learning algorithms, picking hyperparameters, and tuning those hyperparameters so that they fit your model the best. Once it's done all that, it creates a hosted endpoint that you can then use for predictions. Okay, so Alicia, can you tell us how this then helps?
I can try, Mike. So just to sort of go back and talk about remind you of the specific problems that we're talking about. We're in Syria, 13 million people in need, Syrian pound has depreciated, rising cost of food, wages are stagnant. So what we want to do is be able to forecast out the number of people who need humanitarian food aid in Syria. So I kept these two little icons here at the top right of the screen because I just want everybody to remember throughout this process that we're talking about very few people with very limited technical bandwidth. And so we really set out to understand how we could build a forecasting architecture that was really going to eliminate a lot of that undifferentiated heavy lifting for our analysts who could then just work with the results to apply them to the context that they're working in. So the particular Syria pipeline that we're talking about gets data from two different places. The first place is an API that pulls data from the UN Office for Coordination of Humanitarian Affairs, has a website that hosts data, humanitarian data exchange. This particular data set is published by the World Food Program. It's public data. You can go pull it yourself. That data set has every country in the world in which this data is being collected, every food item for every country, and that's all jammed into a single data set. So we grab that whole global data set. We do some processing with Glue to pull the Syria data out, and we dump that Syria data into its own sort of Syria S3 bucket. But we also need a second data, and that data has to come directly from the Syrian analyst. So he is receiving a proprietary data set from a partner organization that they work with. And he needs to give us that data in order to integrate it with the food price data that we've already gone and gotten and cleaned up. So he just uploads that into S3. And when he uploads that directly into S3, that kicks off an event bridge, which starts a step function, which is going to orchestrate my pipeline. So that step function then hits Fargate and starts a Fargate task. That Fargate task is running a container, which has my pre-processing script, which all that pre-processing script really does is a Python script to integrate those two data sources I was talking about and to put it into the particular format that's required by Amazon Forecast. Like Mike mentioned, Forecast is a little bit particular. You got to have the right column names and they got to be in the right order and all that stuff. So we use that script just to ensure that that goes smoothly into Forecast. Then it actually runs the forecast. So it uses the Python SDK to hit the Forecast API, generates our predictions. Those predictions get generated in a couple of different files. So of course we have a post-processing script. All of this is happening in the same Fargate container over the course of probably a couple of hours usually. And then once that's all been post-processed, that gets dumped back into my results bucket. So now I have a nice clean set of results, which I've actually reintegrated with the historical data set. So now it can be available for all kinds of different things. That CSV can be uploaded straight into some sort of visualization tool if you want, or what we do is we use Amazon SES, the simple email surface, generate a pre-signed URL, which I then email back to the analyst, who does some more analysis and messing around with it before he's able to actually publish it to his partners. So this is what that pipeline looks like. My analyst is required to do two things. He's required to upload a data set and then receive an email. And that's it. He has the results that he needs. So this is an example of how we've kind of thought about developing these pipelines to really support analysts who aren't able to get into that AWS console and understand how to use those tools themselves, but still need to be able to generate those kinds of results. So at the end of the day, the work that we did with the Syria team resulted in a forecasting model that averages about 88% accuracy per item. So we do the forecast by individual food item. It also includes wages. So, you know, like in industry, if you're talking about trying to predict sort of demand on a large website or something like that, like 88% is oftentimes seen as not a great result. But when we started this project, the team was looking for like, if you can get us within a ballpark of plus or minus 20%, we would be ecstatic. So this is like an incredibly powerful tool for these teams to be able to put out into the humanitarian community of practice, and the humanitarian community of practice can use those results to actually understand where to better plan for resource application as they're doing their program design. So the team ultimately published the initial model that we built as a component of this report that you can see on the screen. It's really on the overall depreciation of currency. But then they decided to really expand their work in the quantitative space. So they've done some other really interesting things like using nightlights as a proxy for economic development, and also recently soil moisture for forecasting different crop yields. And so admittedly, I can take no credit for most of this. Their quant analyst is amazing. But because we've kind of been able to get these results out into the world, that's had a hugely positive reception from the international community. And the team is really looking at wanting to do this for the long term, wanting to scale that work up. So now we're working together to figure out how AWS is going to continue to support this work moving forward. So that's a really good starting point for sort of our journey in understanding and using elasticity to sort of like support our teams on the ground. But I want to talk more generally about the idea and the framework that we're using when teams approach us for a problem set like this. And so to do that, I'm going to use another use case, which is the economic crisis in Yemen. So really, what I've talked a little bit about is forecasting and analysis, but data collection and aggregation and storage are the two biggest components of what we're asked to do on a daily basis. Probably 85 or 90% of the work that I do on AWS falls into those data collection and storage buckets in terms of taskings. So the best example for this is the work that we've done to support the Yemen Economic Tracking Initiative, which we refer to as YETI. So Yemen, the conflict began in 2015. There's about 24.3 million people in need. It is, like, in terms of people affected, I think the largest crisis in the world at the moment. And again, we have a similar sort of like depreciation, inflation type of economic event that's occurring in this country. As you might have guessed, data is fragmented, collection is often interrupted, and everything comes in varying formats, sources, and quality. And so there's really not like a robust number of data sets that we just stream into our AWS environment like you might do with other types of information, right? It's tons of different governmental, non-governmental, international organizations that are publishing this all over the place. It can be nicely packaged in an API. Sometimes we have to do HTML scrapers just to get it off of a website. And you know, on top of that, it's an extremely volatile conflict, so at any given time, that data may no longer be available. So it's really a complicated and takes a lot of work to get the information together when we talk about trying to do something for the Yemen context. So what's the real challenge here is just how do we get information on Yemen's economy so we can just support those decision makers on the ground, especially when we're talking about not just aid provision, but also economic policies and economic recovery. So again, the crisis analytics teams are quite small. We have limited technical bandwidth. So what we wanted to do is just pipeline everything, automate as much as we could so that nobody had to go out and get information. The folks that are going out and getting information are doing it on a qualitative basis because that's their job, right? To collect that additional qualitative context so that we can bring that into the environment as well. So we wanted to eliminate the need for any of them to have to go to a website and download a spreadsheet and upload it anywhere. So this is what sort of like our baseline pipeline looks like when we talk about data collection. It's typically time-bound. Usually organizations publish on some sort of time scale. It's usually days or weeks. Sometimes it's a monthly basis, but it's not usually regular. So with EventBridge, what we're able to do is kind of say, hey, can you go check for this monthly data set maybe a couple times a week and see if it's been published yet. So we can do all kinds of different things with that to time it to make sure that we get that data as soon as possible after it actually is published. We use step functions to orchestrate almost all of our pipelines. This generally hits a Lambda, which hits an API. We bring that into AWS Glue, whether it be doing a Glue data brew job or using like the actual Glue platform, to run some kind of Spark job behind it. And then we dump those results into S3, which of course makes those results available now. Folks can get that data either through some kind of API, or we can upload it we can download it, upload it, put it into a visualization platform, put it into a website, and that's it. Using this strategy, we're able to collect, process, and surface more than 20 different data sources that, again, are published as multi-tab Excel files. They come from social media like Telegram or Twitter. Sometimes it's tables in PDF, and sometimes, they are nice, tidy CSVs. But this approach is really flexible, and you just have to think about how you can hook these services together to prevent having to manage a lot of stuff, but still be able to get done what you need to get done without also using services that are just overkill for the amount of data that you're actually using. So if you think about it in a plug-and-play way, maybe we want to use another Lambda to process it instead of Glue. Sometimes that goes into RDS instead of S3. So it's a super flexible approach that we use. We use sort of this plug-and-play mentality to say, well, I can just put a different service there if that's what's required for this particular data set. So sometimes it does get a lot more complicated. Obviously, maybe we have a trigger, a step function. We call it an API, which is actually like some sort of HTML scraper. We put the raw data in there. We need a Lambda to call textstract because this is actually just a PDF with a table in it. And oh, by the way, that table is in Arabic, so we need to maybe translate that. Then we can put it into S3 and make that information available. So it's okay for us to kind of do things this way because most of these services are priced for scale. So if I need to add 20 Lambdas to my pipeline, it's kind of okay because there is no way that I'm making 1 million Lambda calls a month to get charged for Lambdas. I'm simply not doing it, right? I'm not dealing with that volume of data. So as a small team working with smaller volumes of data, this is an extremely affordable way to go about it without, again, having to spend time managing a whole lot of stuff. I also do a lot of things like writing multi-use Lambdas, where a single Lambda can be called with a configuration file that can be used for multiple types of data sets. I don't really need to worry about concurrency because, again, I'm working on scales of days or months in terms of publication, so I don't need to worry if this Lambda is going to get called at the same time in the same second because it's sort of a different world that I'm living in. So with YETI, this is really like the direct outcome. We have a website. You can go to it if you want. I think the URL is at the end of this presentation. But we use some third-party visualization tools. We're hosting it on a third-party web hosting service right now, but we're working on bringing that all into AWS, so it's all sort of hosted internally, bringing that data into a more sort of sustainable storage model and stuff like that. So this is going to get a lot more exciting looking in the very near future. But YETI has become really the place that the humanitarian community is going to get information on the Yemen economy. So phase 1 and 2 of this project, we really haven't done any analysis at this point, right? All we've done is gone and collected, stored, and surfaced this information in a useful way so that people can look at information together, they can overlay it, they can look at quantitative and qualitative data together. And that's really powerful for organizations that don't have the ability to hire a contextual expert as well as a quant analyst, right? And in addition, it's really reducing a lot of duplication of effort within the humanitarian community of practice working on Yemen, because it's just one organization that's doing that data aggregation and using those cloud resources, and not every organization trying to do it for themselves. So if I wanted to give you a couple of takeaways before I even go through the ones on the screen, the first one I'll say is if you're a data publisher, whether you're a local government or a humanitarian organization, take a hard look at how you're publishing your data. If you can do something to make your data require less processing and management, then you will make a whole lot of people's lives a lot easier. So whether that's deleting that extra row before your headers on your CSV file, or like changing that multi-tab Excel into a different format, like whatever it is, take a hard look at your publication standards within your sector and see if there's something you can do to just make life easier in terms of using data. With regards to AWS specifically, my 3 takeaways from this talk are: 1, if you're a small team with limited resources, look at that fully managed service end of the continuum, right? Don't require your analyst to also be a network engineer, to also be some kind of data engineer, to also be, right? Like, you can reduce that undifferentiated heavy lifting by using fully managed services. That plug and play mental model, I think, is really important. Understand that AWS's services are designed to be linked together in this way, right? Use those step functions or event bridge triggers to be able to orchestrate pipelines, and understand that you can add to, take away, replace, however you need to. But once you have that mindset, it makes it really easy to extend this framework to other data sets as you go along, right? And then the last bit is take advantage of AWS's pricing, because their pricing model is designed for organizations like Amazon, right? People that are processing millions of bytes of data per minute, but that's not what I'm processing. I'm processing relatively low volumes of data so that folks can make decisions. Even though that's hugely impactful and hugely powerful for these organizations, I'm not paying a whole lot for it, because managed services are expensive per byte, but I'm not processing that many bytes. So look at your total costs, not at, oh, this is too expensive because it costs more per byte. And AWS does a really great job of that kind of pricing model, which makes it accessible for organizations with a lower budget, because your overall costs stay low even when you are using these more expensive, fully managed services. I'll let Mike wrap us up.
All right. So I recommend check out the Mercy Corps website, see some of the cool work that they're doing. This is the URL for the YETI website. Check that out. It's really cool to see the work that Mercy Corps is doing to help the crisis in Yemen. And if you'd like more information about some of the services I mentioned, those are the URLs for Amazon Forecast and for AWS Glue. We'll open it up for questions now, but as we do that, I would ask that you take a moment to complete a survey, and appreciate your time, and with that, we'll open it up for questions.
Question?
I can just talk loud.
You can just talk loud. I think it's okay.
I'm just kind of curious.
Oh, okay.
Thank you very much for the presentation. I'm Gordon with the State Department. So, oh, there it is. So I'm kind of curious, when you're migrating your website from where it's currently being hosted into AWS, what resource on AWS are you using to do that?
Yeah, that's a really good question. So this is maybe not a great example of what I've talked about, because we actually chose just to build a custom Django framework and host it on EC2, but that's because we have access. Specifically, one of our partners, it has time with their actual developer to do that build out. However, we did kind of develop a strategy that we were going to go after if we didn't get that resource, and that was to continue to build our pipelines as I've described, so that our backend was really kind of sitting on S3. We talked about maybe or maybe not putting it into RDS. RDS is a managed database, so there's not a whole lot of lift that goes on with that, except for the database design. One of the issues we have with that, though, is that in the humanitarian data sphere, schemas are really unstable. And so you're always having to go back and do kind of schema maintenance and that kind of stuff. So that was maybe not a great option. So the route we were considering was putting that data into S3. You can read it just into Athena as is, and then using Amplify to just host a Java front end. So that is kind of the strategy that we're using for projects like that moving forward when we don't have dedicated developer resources.
Can I ask one more?
Sure.
So a lot of the issues that you've raised are exactly the kinds of things that I face on a regular basis, so thank you very much. Sorry, now I'm blanking. Give me just 1 second. Oh, yeah, so in your pipeline, right, you showed, right, you've got this way of standardizing your data, right, and eventually emailing it out to your analysts, right? that is all like preset for them. Is there any way that you can have like a front end where the user can kind of select what it is that they want, as opposed to being pre-packaged and sent out to them? Because right now, I'm using a Shiny app through EC2, and like you've discussed, it's a lot of overhead to manage all that.
Yeah, that's a good question. I don't think we've gotten really that far in our development, but I think that's sort of like the dream extension of it, right? Is to be able to kind of do that live, that sort of like the changes live. I don't know if you have any thoughts on that.
Well, again, I'm always going to recommend that you do something that requires as little maintenance as possible. But I don't think there's a single answer there. Any other questions? All right, thanks everyone.